Welcome to digital classes. Today I am going to discuss an interesting topic representing real numbers, that is rational and irrational numbers on number line. Students, already you have learnt about natural numbers, whole numbers, integers, rational numbers in your earlier classes. Do you remember? Okay. So, let us recall those concepts. By the end of this session, you will learn number system and representing rational numbers, irrational numbers on number line. Students, here we have a collection of numbers like 1, 2, 3, 4, so on. Can you tell the name of this number set? Yes, that is the collection of this natural numbers called as natural number set, and it is denoted with letter n. If we include 0 to this number set, that is natural number set, we get another collection like 0, 1, 2, 3, 4, so on. Can you tell the name of this number set? Yes, that is whole number set, which is denoted with the letter W. Next, the collection of numbers like 0, 1, 2, 3, 4, so on, to the left of 0, minus 1, minus 2, minus 3, minus 4, so on, are called set of integers, which is denoted by I or Z, generally denoted by Z. Here minus 1, minus 2, minus 3, minus 4 are called negative integers. Next, 1, 2, 3, 4, so on are called as positive integers. Here 0 is neither positive integer nor negative integer. So, here observe natural numbers, all natural numbers are lies in whole numbers, and all whole numbers are contained in integer set. So, we can say that natural number set contained in whole number set and whole number set contained in set of integers. So, n is subset of W and W is subset of Z. Next, what type of the numbers are missing in this set of integers? Did you observe, students? Yes, those are rational numbers. Till now we have learnt about a natural number system, whole number system and integer system. Now we recall the definition of rational number system. The definition of rational numbers: the numbers which are in the form of p by q, where p, q are integers and q not equals to 0 are called rational numbers. So, the set of rational numbers is denoted by q. Students, did you observe one condition? Here q is not equal to 0. Why it was mentioned? Y means division by 0 is not defined. So, that is why the condition was mentioned. So, this is the definition about rational numbers. Now, let us observe set of integers. Are these set of integers belongs to rational numbers? Okay, can we check? Here take one number minus 2. Minus 2 can be represented as minus 2 by 1. So, minus 2 by 1 is of the form p by q. So, where p is minus 2 and q is 1, both are integers and q is not equal to 0. So, therefore, minus 2 is rational number. Next, 4. 4 can be expressed as 4 by 1. So, which is of the form p by q. So, where p and q are integers and q not equals to 0. So, therefore, 4 is also belongs to rational number. So, what is our conclusion? All the integers are rational numbers. So, already just now we have concluded that all natural numbers, whole numbers are integers. So, as they are integers, so they are also can be expressed as in p by q form. Therefore, all natural numbers, whole numbers, integers are rational numbers. Now, observe the following numbers. Here we have 2, minus 3 by 8, 0, minus 5. Let us see to which number set these numbers belongs to. So, first of all, I am taking 2. 2 is in natural number set and 2 is in whole number set, 2 is in set of integers. So, 2 can be expressed as 2 by 1. So, which is of the form p by q, therefore, which is rational number. So, we can say that 2 is in natural number set, whole number set, and integer set and rational number set. So, next take minus 3 by 8. Minus 3 by 8 is not in natural number set, it is not in whole number set, it is not in set of integers, but minus 3 by 8 can be expressed as p by q form. So, which is a rational number. So, we can say that minus 3 by 8 is in not in natural number set and not in whole number set, not in integer set. Minus 3 by 8 only it is in rational number set. Next take the number 0. 0 is not in natural number set, it is in whole number set and it is in integer set. 0 can be expressed as 0 by 1. So, which is of the form p by q. So, therefore, which is a rational number. So, we can say that 0 not belong to natural number set, but 0 in whole numbers and integers and rational number set. Next take the number minus 5. Minus 5 does not belongs to natural number set, does not belong to whole number set, but minus 5 is in integers, set of integers. Minus 5 can be expressed as minus 5 by 1. So, which is of the form p by q. So, which is a rational number. So, students, minus 5 is not in natural number set, it is not in whole number set, but it is in integer set and rational number set. So, students, till now we have learnt about different types of sets. Now, you are able to identify the given numbers belongs to which set. Okay. So, now let us observe some decimal formats. So, here we are going to learn the rational numbers, irrational numbers definitions by using decimal forms. Okay. So, for that first observe divisions. Here I am taking the number 1 by 5. Already you have learned in 8th class the conversion into decimal form. So, 1 by 5, the division is like this. So, divide 1 with 5, you will get the 0.2. In this way, divide 1 with 4, you will get 0.25. Divide 2 with 9, you will get 0.2222, so on. Divide 56 with 99, you will get 0.5656, so on. So, these are the divisions already you have learnt in previous class. Now, observe the following numbers. Here we have some decimal numbers 0.2, 0.25, 0.222, so on, 0.5656, so on, 0.10, 100, 1000000 and 0.300, 303, so on. Do you find any difference among these numbers? Yes. The first two numbers are terminating decimals and the next four numbers are non-terminating decimals. We can write like this. Decimal numbers are two types here, terminating and non-terminating. So, first two comes under terminating and next four comes under non-terminating. And in non-terminating decimals also we can observe some differences. So, first two 0.222 and 0.565656, so on. So, here some numbers are digits are repeating, in next two digits are not repeating. So, in first two digits are repeating or recurring, in next two digits are non-recurring. So, we can again divide it like this. So, first two 0.222, 0.5656 are called as non-terminating recurring decimals and next two decimals are non-terminating non-recurring decimals, and these 0.222 can be represented as 0.2 bar and 0.565656 can be represented as 0.56 bar. Now, finally, we can observe decimal numbers are in three forms. One is terminating and second one is non-terminating recurring, and third one is non-terminating non-recurring. So, in terminating like this 0.2, 0.25, in non-terminating recurring the digits will repeat, in non-terminating non-recurring the digits neither terminate nor repeat. Now, the question, can we write these decimal numbers into P by Q form? We can check. Now, first of all, see terminating type. So, these terminating type decimals can be represented as P by Q form. So, 0.2 can be written as 2 by 10, 0.25 can be written as 25 by 100. In shortest form 0.2 is 1 by 5, 0.25 is 1 by 4. So, these decimals can be represented in P by Q form. Non-terminating recurring decimals also can be represented as P by Q form, but non-terminating non-recurring decimals cannot be represented in P by Q form. So, here we can define rational numbers, irrational numbers by using decimal numbers. So, the numbers which are the decimal numbers which are in the form of terminating or non-terminating recurring decimals, those are called as rational numbers, and the decimals which are non-terminating non-recurring decimals are called as irrational numbers. In another form we can write the numbers which are not rational are called irrational numbers. Now, some more examples of irrational numbers. So, these are the three more examples for irrational numbers which are neither terminating nor repeating the decimals. These are non-terminating non-recurring decimals, and some more irrational numbers are in another forms also, like root 2, root 5. So, like roots, how can we say these numbers are irrationals? Here I am taking first 10 natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then I am applying square root for all natural numbers. So, then estimate the values. So, these are the values of square roots of first 10 natural numbers. Students, observe here square root of 1 is 1 and square root of 4 is 2, square root of 9 is 3. So, the property is square root of perfect squares, square root of perfect squares, here 1, 4, 9 are perfect squares. So, square root of perfect squares are rational numbers. Now, square root of non-perfect squares can be represented as non-terminating non-recurring decimals. So, these are called as irrational numbers. Next, definition of real numbers. The collection of all rational and irrational numbers is called real numbers. The set of real numbers is denoted by the letter R. And also here we can see the total number system in a single frame. So, here natural number system contained in whole number system, and whole number system is contained in integer set, and integer set contained in rational number system, and here irrational numbers. So, here rational numbers and irrational numbers are disjoint, and all these contained in real number system. So, this is the clear picture of our number system till we have learnt. Okay, natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Till now we have learnt about rational numbers, irrational numbers, real numbers definitions. Now, the interesting topic, how can we represent these rational and irrational numbers on number line? Okay, let us see. Let us learn how to represent rational numbers on number line. First, represent 5 by 3 on number line. First, take number line, locate 0, 1, 2 on number line. Here 5 by 3 is given number, right? So, 3 is in the denominator. So, divide each unit into 3 equal parts. So, take 5 parts out of these. the fifth point on the right of 0, this is 0, the fifth point right of 0 represents 5 by 3. So, this is 5 by 3. In another way, 5 by 3 is improper fraction, right. So, 5 by 3 is improper fraction, it can be converted as mixed fraction. So, here 1 2 by 3 in mixed fraction it is can be written as 1 2 by 3. So, it indicates the number lies between 1 and 2, here 2 by 3 indicates after 1 the second point, this is the 2 by 3. We have divided into 3 equal parts, the second part is our number. Okay. So, in this way also we can represent rational number on number line, represent 5 by 6 on the number line. In the same way, here 5 by 6 is proper fraction, already we have learned the proper fraction, value of the proper fraction lies between 0 and 1. So, 5 by 6 lies between 0 and 1. So, in the denominator of 5 by 6 we have 6. So, divide this unit into 6 equal parts. The fifth point on the right side of 0, the fifth point on the right side of 0 represents 5 by 6. So, this is 5 by 6. So, like this we can represent given rational numbers on number line. Next, let us learn how to represent irrational numbers like root 2, root 3, root 5 and so on number line. So, before going to identify, before going to locate irrational numbers on number line, so first of all we have to learn this concept. Here observe OPQ is right angled triangle with OP is equal to PQ is equal to 1 unit. So, then how can we find the value of the hypotenuse OQ? We have a beautiful property, that is OQ square is equal to OP square plus PQ square, hypotenuse square is equal to sum of the squares of another two sides. So, this is famously known as Pythagoras theorem, which we will learn in our higher classes. So, now we will find value of the hypotenuse. So, here OQ square is equal to 1 square plus 1 square, that is 1 plus 1, 1 plus 1 is 2, then OQ is equal to as OQ square is equal to 2, then OQ is equal to square root of 2. So, this concept is useful to locate irrational numbers on number line. Now, take number line, locate the points -2, -1, 0, 1, 2 integers on number line. Let us denote O with capital O and the point 1 with P. Then here OP is equal to 1 unit, the length of OP line segment is 1 unit. Now, draw a perpendicular line PQ with 1 unit which is perpendicular to OP. Now, join O and Q. Now, OQ is equal to root 2, right. So, how we got root 2? Just now we have did this calculation by using Pythagoras theorem. Now, take center as O and OQ radius, draw an arc like this. Draw an arc with the center O and radius OQ which is equal to root 2 units. So, that arc meets number line at L. So, that the point L represents root 2. So, like this we can represent the number irrational number root 2 on number line. Next, how can we represent root 3? So, follow the same steps, draw a perpendicular line RQ which is perpendicular to OQ, the length of the RQ is 1 unit. So, join O and R, join O and R. So, now OQR is right angled triangle. So, now we are going to estimate the value of hypotenuse OR by using Pythagoras theorem. So, here hypotenuse square is equal to sum of the squares of another two sides. So, side square plus side square, that is OQ square root 2 square plus 1 square root 2 square plus 1 square, root 2 square is 2, 1 square is 1. So, 2 plus 1 is 3. So, then OR square is equal to 3, then OR is equal to square root of 3. So, like that we will get OR as root 3, 2 plus 1 3 and hypotenuse is equal to root 3, right. So, here OR value is root 3. Now, draw an arc with the center O and radius OR is equal to root 3 units. That arc meets the number line at M. Okay. So, that M represents root 3. Okay. So, students, here we have learnt how to locate root 2 root 3 on number line. In the similar way, we can locate root 4 like this in the same way. Draw perpendiculars and continue the same process. So, root 5 like this, draw an arc which meets number line at that point. Next, root 6 like this, continue the same process. Okay. So, like this we can, if we keep on continuing like this, we get a spiral like structure which is called as square root spiral. So, this is beautiful square root spiral. This is also represent a root 10 on number line. So, in previous method that is somewhat difficult to locate root 10. So, now root 10, what is the, students, please tell what is the square root of perfect square just less than 10 s, that is 3, square root of 9 is 3. So, take 0 with O and 3 with P, OP is equal to 3 units. Now, draw a perpendicular at 3, that is PQ, perpendicular to OP, PQ length is 1 unit, and join OQ. By Pythagoras theorem we can estimate OQ, that is root 3 square plus 1 square, that is root 10. Now, draw an arc with the center O and radius OQ which meets the number line at K. So, that is root 10. Okay. So, this is the simple way. This is the simple way to find root 10 on number line. Like this we can locate root 100, root 121 like that also. So, students, what have we learnt till now? Definition of rational numbers, decimal form of rational numbers, and representing rational numbers on number line, representing irrational numbers on number line using square root spiral. So, students, till now we have learnt a beautiful concepts like rational numbers, irrational numbers by using decimal representation, and representing rational numbers, irrational numbers on number line. So, these are the beautiful concepts we have learnt. So, now you are able to solve the problems related to these concepts. So, here I am giving some problems, please solve yourself. So, first problem is, give an example which is a rational number but not an integer. Second problem, locate minus root 2 minus root 3 on number line. So, already we have located root 2 root 3 on number line on right hand side of 0. So, follow the same process to left hand side, then you will locate minus root 2 minus root 3 on number line. Next, third question, is every rational number real number? Next, fourth one, represent 7 by 3 and 3 by 7 on number line. So, students, for better understanding of these concepts, solve the worksheets, please visit the official website of SIET for worksheets. So, students, we will meet again with another lesson in next session. Okay? Thank you.